investigation for 1,700 days.
Disclaimer: the content on this channel is meant only to provide helpful insights, tips, and information on certain subject or topic. While we strive to provide accurate and up-to-date knowledge, this is not a substitute for professional advice. Always consult a qualified expert or professional for your specific needs. We encourage you to use this content as a guide for learning and additional information. If you think this does not fit what you want, please skip the video.
Particle arrangement and motion. Gases have particles that are widely spaced apart and move independently of one another. Key characteristics include high kinetic energy. Gas particles possess high kinetic energy, which allows them to move rapidly in all directions. This motion is largely translational. Random motion. The movement of gas particles is random and chaotic, leading to frequent collisions with each other and with the walls of their container. Elastic collisions. When gas particles collide, they do so elastically, meaning there is no net loss of kinetic energy in the system. This is crucial for maintaining pressure and temperature. Intermolecular forces. The intermolecular forces in gases are minimal compared to solids and liquids. Negligible forces. Gas particles are far enough apart that intermolecular attractions have a negligible effect on their motion. This is why gases expand to fill their containers completely. Temperature greatly influences gas behavior. As temperature rises, the kinetic energy of the particles increases, leading to faster motion. This can increase pressure if the volume is constant. Lowering the temperature can condense gas into a liquid as the kinetic energy decreases and intermolecular forces start to take effect. The unique motion of gas particles results in several properties. Gases expand to fill the volume of their containers, demonstrating their ability to occupy available space. Gases are highly compressible because of the large amount of empty space between particles. This allows for significant volume reduction under pressure. The widely spaced particles give gases a much lower density compared to solids and liquids. In summary, gas particles are in constant high-energy random motion with minimal intermolecular forces. This behavior leads to the unique properties of gases, including their ability to expand, compress, and occupy any available volume. The behavior of gas particles is explained by the kinetic molecular theory, which outlines several key postulates. Gas particles are in perpetual motion, and their kinetic energy is directly proportional to the absolute temperature of the gas. Collisions between gas particles and between particles and the walls of their container are elastic, meaning that energy is conserved. There is no loss of energy during collisions. The average kinetic energy of gas particles is related to temperature. Higher temperatures result in greater average kinetic energy and faster particle motion. The kinetic energy of gas particles increases with temperature. This relationship is expressed in the formula Ke equals 3/2 kT, where Ke is the average kinetic energy, K is the Boltzmann constant, and T is the absolute temperature in Kelvin. As temperature decreases, the kinetic energy of gas particles decreases. If the energy becomes low enough, particles can form liquid, condensation, or solid, freezing phases depending on the conditions. Gases will expand to fill the shape and volume of their container. This is due to the random motion of particles, which naturally spreads out to occupy available space. Gases can be compressed significantly because of the large amount of empty space between particles. When pressure is applied, particles can be forced closer together. The low density of gases arises from the large distances between particles. This is why gases weigh less than liquids or solids at the same volume. Gas particles can mix and spread out in a process called diffusion. This occurs because of the random motion of particles, leading to a gradual mixing of different gas types. Effusion is the process by which gas particles escape through a tiny hole into a vacuum. Effusion rates depend on the mass of the gas particles, with lighter particles effusing faster, according to Graham's law of effusion. In summary, the motion of particles in gases is characterized by high-energy random movement and minimal intermolecular forces. These factors result in the unique properties of gases, such as their ability to expand, compress, and diffuse. Understanding these concepts is crucial for fields like chemistry, physics, and engineering, where gas behavior plays a significant role in various applications.